Hello everybody, this will be our third example where we value security prices using the state contingent claims with the principle of no arbitrage. Alright, so it's quite a mouthful, I know, but at the end of the day, the backbone of the method, the algorithm that we introduced is linear algebra and matrix multiplication, and this is just a very neat application of how linear algebra is useful in solving systems of equations. All right, so here is the problem. Again, this is an example of a two-period model. So we have the current prices. So today, everything is known today, and there is, well, at least for those two securities, those four securities, I should say, and then there's the uncertain future. Given the uncertain future, what should be the prices of these three securities? So that's what the question, where the question mark is, right? So let me actually go ahead and put 3 question marks over there. The actual question is asking those 3 question marks. Even though they are blanks here and we will fill out in just a few minutes, that's not the essence of the problem. The essence of the problem is to be able to value securities, any security, given enough securities and their values, basically. So if these securities are fairly priced, then we should be able to derive the price of any security, any number of securities. We can increase the list and create more and more securities. For instance, I can't resist. Let's create another one. Asset D, let's call it. I want to calculate the value of asset D, given that this asset is basically doing the opposite of what asset C is doing. It's giving $40 in state 2 and 4 and nothing otherwise. Okay, so in that sense, it's like the opposite of asset C. If you were to combine the two, then you can create a portfolio which will give you a certain outcome, basically. But anyhow, so how do we do with it? Well, like we said, we have a certain algorithm which we follow. The first step of the algorithm is to construct the coefficient matrix, but as you guys can see here, we are missing some values. Let's start out by filling out those values. It's very easy to do it because this security here is call option on stock W. Stock W is this one. So if you have a call option with a strike price of $60, this call option will only be exercised in future states where the stock price exceeds $60. So it will go worthless. Let me change the color here. There we go. So it will go worthless in state 1 and 2. 0 basic, or actually let me write a function for you. The maximum of the two numbers. Which two numbers? The maximum of this number versus 60. So which one? Oh, or sorry. The difference, right? So okay, so the maximum between 0 and this number minus 60, basically. Do you see what I did here? All right, so it goes worthless here. Do you guys see that? And I can pretty much extend the formula and boom, I would be done. So what I did is the following. I know that this call option will only be exercised in future states where the stock price exceeds $60. And whenever the stock price exceeds $60, the owner of the call option will only get the difference. Why? Because you have the right to purchase the call option at $60. And as soon as you exercise your right and purchase the call option at $60, if state 3 is the state of the world in the future, then you know that you can sell those stocks at $70 a piece after having purchased them at $60, so you can make a profit out of the difference. If instead state 4 were to materialize, then the stock W would be worth $85. Again, it will be more profitable for you to exercise your right. 85 minus 60 is 25, and that's the value of the security. So in a sense, all you do is you look at the difference between the strike price and the stock price, stock minus strike, and if that number is positive, you exercise. If it's negative, you just put 0. You don't exercise your right. And we can pretty much do the same thing here. Oh, sorry. This one is a put option. Put option is the other way around. Okay, put option gives you the right to sell the security, right? Oh, wait a second. This put option is Oh yeah, I forgot to change these numbers. Sorry for that. Earlier I was devising another example. Okay, so these are ridiculous. Hold on. I decided to change this one to $3.19, and this one should be more like no, this one is $8.19. Let's make this one 2.05. There you go. This one is more reasonable. All right. So yeah. So the put option gives you the right to sell the security at $20. And well, if the future state of the world is sorry, this is stocks X. Sorry, these are the numbers that I should focus on. So if the future state of the world is yes, okay, if the future state of the world is state 1, then yeah, your option will go worthless basically. Yeah, there's nothing there. If the state of the world is 25, why would you exercise your right to sell it at 20 while you can sell it at 25 in the marketplace? So you are not gonna exercise your right again. You're not gonna exercise your right here either. And finally, this is the only state where you will exercise your right, and you will get an outcome of $5. Do you guys see that? Alternatively, I could have written a formula like I did in the previous. I think this one is okay. Let me change this one a little bit because it is not realistic. 0.85 cents. I'm able to guess the prices using financial theory, a skill that those of you in the Master of Financial Analysis program can later on develop. But for the time being, yeah, so these are just some numbers basically. Don't worry about the numbers. All right, we are behind the math. All right, okay, so now I have a full coefficient matrix, right? Let's go ahead and first start with the coefficient matrix. So what I did is I already have the let me delete that placeholders. So this will be my coefficient matrix. Wait a second, the coefficient matrix is exactly this thing over here, right? All I will do is I will just Control C and then paste it, enter. Do you guys see that? It's pretty good. It entered the values. Oh, sorry, these are not values. These are, okay, so let me Control Z. I just want to enter the values. Okay, let me right click, I guess. Because, yeah, if I enter the formulas, it can mess up my calculations. Okay, there you go. So it entered the values only. So these values are the same as those values. Now I want to go ahead and calculate the inverse. This time I'm not going to try to find the formula from the formulas, but rather, because we've done many examples by now, yeah, so I know the exact name of the formula. I want to calculate the inverse of this matrix. Close parenthesis, press enter. There you go. Wow. So there's a lot of minuses, so which is kind of interesting. The prices might not be compatible. Let's see if it will give us some nice results. We also have a vector of values, which is exactly these. So I just Control C these values and right click and then paste. And finally, the prices of state contingent claims would be, so I want to calculate this number. It is basically the same thing, equal matrix multiplication. Let's see if the numbers will come out negative for some reason. They might. In that case, I can just revise the numbers inside the cells. All right, so the matrix multiplication of the inverse coefficient matrix and the vector of values. That's it. And then press enter. Oh gosh. All right, there you go. I was expecting such a thing. While I paused the video, I just revised these numbers. Yeah, so that hopefully this time it should bring us some better results. Yes, because in the other cases when when the numbers are not adjusted carefully, the state contingent claim prices turns out to be negative, which is absurd, right? All right, so these are the current prices for these securities. I didn't change any of the numbers here. All I did was to revise these numbers. So because I didn't change any of these numbers are still the same in the matrix of coefficients. Its inverse will be the same. The only thing which changed is these numbers changed, the prices, the current prices of these 4 securities. So as a result, I reflected it here. Let me just go ahead and put a $sign. Okay, there you go. They are the same numbers, as you guys can match. Now let's go ahead and calculate these numbers as a result of matrix multiplication. Multiplying basically the inverse matrix with what? With the vector of values, and that's it. And that should give us the state contingent claim prices. There you go. Let me just go ahead and put a $sign there. All right, so the state 1 contingent claim is 35 cents, state 2 contingent claim 25 cents, and so on. So these are the values of these state contingent claims. Based on these values of state contingent claims, now let's go ahead and value these 4 different securities. Let's start with the first one. So this is a call option on stock X with a strike price of $25. Well, these numbers are not given. Let's first calculate these numbers, right? So because we need them. All right, so if a stock call option on stock X has a $25 strike price, right now the stock is selling at $29.75. So the stock will be if in future state 1 the stock is worth $20, so you don't want to exercise your right, because you can just simply purchase the stock at $20 from the market. Why would you exercise your right to purchase that $25 for that individual who signed the contract, the call option contract with you, right? You can think of the party which is selling you the call option contract like an insurance company. So you have this contract, it's waiting there, and if a bad state of the world happens, then you can go ahead and exercise your contract. Otherwise, your contract goes worthless. All right, so this is a state where it goes worthless. $25, again, it goes worthless. $30, yes, it's worth $5, right? It is just the difference between $30 and the strike price. And so it's equal to 30 minus the strike price of $25. And finally, this one, again, it goes worthless. So we are going to go ahead and value this security. You know what? I'm just going to write the formula right over it. So it will be equal to, I need to multiply, these are the number of state contingent claims that I want, each one 0, 0, 5, 0, and these are the prices of each of these state contingent claims. So it's basically a matrix multiplication again. So all I do is multiply this with this. Does that make sense? So a 1 by 4 multiplied by a 4 1 by 1 will give you a 1 by 1 vector, which is just a number basically, and that's it. So this call option is worth $2.25. How about the next one, the put option on stock W with yes, so stock W is this one, this row. I want to make sure I'm not messing it up. All right, so this stock option, this put option, oh gosh, how did I manage to do this here? So there's a question mark here. Okay, there you go. That put option will be exercised only if the stock price went below $48. Then we will exercise our right to sell it at 48 and then pocket the difference. In this case, the difference will be $8 because we will sell it at 48 and then buy it back from the market at 40 basically. Or first buy it from the market at 40 and exercise our right to sell it at 48. And then it will just go worthless in all the other states. All right, so how much is this worth? It's easy. All you do is matrix multiplication again. Multiply this with the prices, the state contingent prices. And that's it, $2.80 it is. How about the other two securities? Pretty much the same. Matrix multiplication. Multiply the units, comma, the state contingent claim prices. That's it. Wow, this one is $40 even. All right, so this one is matrix multiplication, multiply these, comma, the state contingent claim prices. And that's it, we're done. And I can create more and more assets. Valuing these assets is extremely simple. In fact, you can even make a whole soup of assets. Like for instance, asset E is, let me just give you an example. Let's say $20 in that state. Oops. Let's say that it's a bond, $20 regardless of the state, right? So this is asset E is really a bond security, right? Probably a bond. All right, so and let me just go ahead and put a frame around it, and then dollar amount. There you go. All right, except this one is not a dollar amount, this one is just a text. All right, so where's the text? There you go. All right, so the question is, how much is this security worth, which promises $20 in each state? Very easy again. I don't even have to multiply this times this. I can just drag the formula and bring it down. So what I will do is, in the previous entry, I'm just going to fix the previous value, right? So which is really either F4 directly or function F4 in your case. So I'm just gonna fix this one. The others, I will let them float, the first entry. So let me try F4. No, it doesn't work. So function F4, yeah, in my case, function F4 works. So once I fixed it, all I need is just to drag it down, and boom. So this, wait, how can it be $25? Good question. C14 through F14, that is correct, times I20. I feel like there's a problem there. I was expecting to work it nice. Okay, let me just do the calculation manually. My matrix multiplication, multiply, oops, these 4, comma, this. I don't know why it didn't work. Okay, that's weird. Why would I pay $25, which for something which will pay me in the future $20 regardless? Okay, there's a typo there for sure. Let me see where I'm messing up here. 20 times. All right, so if I use the long formula, it would have been, okay, it's kind of weird because, okay, let me just delete that. All I need is 20 times this, plus 20 times this, plus 20 times this, plus 20 times this. Oh, they add up to more than $1. I see. So basically in this economy, there's a negative interest rate. Wow, okay. Okay, so this is an awkward situation. It's like an economy like Japan, I guess. Let me do it again. Matrix multiplication. So these, comma, that. That's it. Whew. All right. So these are effectively the prices of these securities, and it's very easy to get the price of pretty much any security using these methodologies. All right, so I think this was a good example. In my next example, we will have a 3-period model with 2 states only at each period. All right.